Hello everybody. Yesterday we talked about graphing rational functions in vertex form, and that was a simple way to introduce what a rational function looks like. And now we're going to introduce some rational functions that we'll see more commonly, and those will be rational functions in standard form. And so if you look at the graph here on the screen, you'll recognize some things we talked about yesterday. Our graph has asymptotes, a vertical and a horizontal asymptote, and we talked about shifting those yesterday. Today, we're going to start talking about that based on an equation in standard form. When we're talking about standard form, we're talking about a function that looks more like... When we're talking about standard form, we're referring to a function where we don't have the shifts just given to us like we do in vertex form. Standard form will have a value of a rational function where you have an expression over an expression, similar to what you see here on your screen. F of x equals x plus 5 over x minus 6. This is a simple example of a rational function. And so what we're going to talk about today is what we can pull out of a rational function in standard form and use to be able to create a graph. And those critical values that we're going to pull out of the function today, the first one is going to be a vertical asymptote. And we talked yesterday about a vertical asymptote representing an undefined value on a graph. So that function, when it's undefined, we're going to draw in that dotted vertical line, and that's going to represent the undefined value, and our graph is going to approach that just like we talked about yesterday. And if we think about when an undefined value occurs, that occurs when the bottom of a fraction is 0. So our hint is the bottom equals 0. Well, when does that happen? If you look at our function here, x plus 5 divided by x minus 6, when will that bottom be 0? Well, that's going to occur when x equals 6. So therefore, we would have a vertical asymptote at x equals 6, because that is the point where we would have an undefined value, because 6 minus 6 is 0. That creates a 0 on bottom, which creates an undefined value. So that's going to create a vertical asymptote. Similar to our excluded values we talked about when simplifying, and this is one of the reasons we focus on excluded values, is to get us to understand that's a point where this function is undefined, so we'll draw a vertical asymptote at that point. Our other critical value we're going to pull from our graph is a 0. And we've talked about zeros with all of our other functions. Zeros occur when the function is equal to 0. Well, if you think about a fraction, the only time a fraction can be 0 is if the top is 0 and the bottom is not. So therefore, we are looking for the situations where the top of our function is equal to 0, because a rational function is always going to be a fraction. So in this case, x equals negative 5 is going to be a 0 of this function. So what we know about the graph of x equals x plus 5 over x minus 6, we know it will have a vertical asymptote at x equals 6, and we know it will go through the x-axis at x equals negative 5. So we're going to now look at this at a little bit more of an advanced level. Let's go ahead and look at the next step. So the directions for our example are going to tell us to identify the values where zeros and vertical asymptotes will occur for the given function. Well, we need to remember what we're looking for. A 0 will occur when the top is equal to 0. A vertical asymptote will occur when the bottom is equal to 0. So really, here's what we have. In order to find a 0, we're looking for when the top equals 0. So x squared plus 7x plus 10 equals 0 will answer that question. Hopefully at this point we recognize x squared plus 7x plus 10 is factorable. So we factor x squared plus 7x plus 10 down to x plus 2 times x plus 5. And we've done all our quadratic solving, so I'm going to skip the steps of writing it out. We should hopefully know that the zeros are going to occur at x equals negative 2 and x equals negative 5. When we talk about zeros, you simply factor the top and set each factor individually equal to 0. That's where this function will go through the x-axis. It will have zeros at negative 2 and negative 5. In order to find a vertical asymptote, we said vertical asymptotes occur when the bottom is equal to 0. So we simply take the bottom of the fraction and say, when will that be 0? So we said x squared minus 3x equal to 0. And again, this is factorable. I'll give you a hint. Everything we're going to do today will be factorable. So you'll be able to solve all these by factoring. So we factor x squared minus 3x. That gives us x times x minus 3 equals 0 because we can factor an x out of both terms. So then we set each of those individually equal to 0, each factor. And that gives us vertical asymptotes at x equals 0 and x equals 3. So your job today is going to be to look at a function that is a rational function, and you need to find out where all the zeros are going to occur and where all the vertical asymptotes are going to occur. So we're going to set the top equal to 0 and the bottom equal to 0 to do that, and we factor and solve. Good luck.